Today on the Untitled, this is the Bare&Basic video of which many of you have been waiting to see. And if you're just getting to building your own lasers, you've probably seen other videos that talk about taking the CD or DVD laser diodes from these full-sized optical drives and using them to build your very own laser pointers or modules. However, some of these videos can be rather confusing, or just in general incomplete. Trust me, I know. I made a few of these videos myself. However, in this video I'll be remedying all that by showing you how to use nearly any form factor of CD or DVD laser diode in your projects. One of the problems is that some of the laser diodes don't follow the 5.6 or 3.8 millimeter standard size laser diodes and often come in really weird form factors. And these form factors are commonly found in the slim drives from laptops. I actually have a rather large amount of things of which I'll be working with in this video. I got a whole bunch of laser drivers and laser diodes, a whole bunch of optical sleds of which I can harvest even more out, and if that wasn't enough, we can get to the bottom of this box to figure out everything that we need to. I'm not limited by using the common style laser diodes, and neither should you. Let's start out by talking about some of the bare essentials you'll need for your CD or DVD laser diode project. The first bare essential is a soldering iron, and this will definitely come in handy when you go to connect the laser diode to your laser driver. You'll need something to put your laser diode in which case there are a couple of common hosts that you can get for the sizes of 3.8 millimeters and 5.6 millimeters. These are great for laser pointers. Here's the 5.6 millimeter version, and so the laser diode just presses right into the back. You probably have seen this in some of my other videos. And on the front is the lens and the tension spring, and the spring just keeps the lens locked so it doesn't wiggle around and gives it some pressure on the threads. And then the same thing here, except this is the 3.8 millimeter equivalent, so smaller hole. Basically, same thing, different sizes. I also recommend that you get a kit of the red, green, and violet laser pointers. It's pretty cheap to get, but this will give you a little bit more flexibility. Let's see, a reason why I don't recommend a red laser driver purchased off eBay is because they always give me some form of trouble. Here's one that I have with the 700 milliwatt 638 nanometer Oclaro. Demonstrate. The problem is the soft start, and other features are a little goofy. So I'm going to put this into the device, and we're going to see just how long it takes for this laser to actually turn on. And I'll show you another problem. So here I have another red laser driver. Same thing for the 700 milliwatt red laser diodes. And I have a large red LED from a video projector connected to it. And what I'm going to do is I'm going to connect this up to my adjustable power supply and give it about 2.8 volts because the problem is that it don't regulate very well. So take out my turn pot tool. Get the red output from the LED. I'm going to put that up there so you can see the output, and I'm going to turn the potentiometer. And this should change the brightness of the LED, and as you see, it does next to nothing. So that's a little weary on the red laser drivers. Green laser drivers, they're awesome, no problem with them. If you want to go with building a module, you can get a TTL or analog laser driver. There are several different kinds on the market. I love these little guys. They do really well, and I would definitely say avoid these. And the problem is they'll charge up the capacitor, and when the laser diode is cut off from the power, capacitor tends to overcharge, and then when the laser diode is reconnected to the driver, a lot more current goes to the laser diode itself, cooks it. We'll be going over different laser diode types and different driver types, along with the precaution of how to connect them up and how to tell voltage and current and all the other jazz. And with all of that, the meter is another essential. So we're going to be using this in both the voltage and in the current settings. I would also recommend getting a little set of screw terminals with some loose wires, or just another set of wires that you can plug into your meter and solder in the loop between your laser diode and laser driver. Let's go hunting for some laser diodes. So here I have a full-size DVD CD burner combination drive, and on the inside of these there's usually the 5.6mm laser diodes, so they work great with the hosts that you can find online pretty easily. The laser diodes are located on the optical sled, and that is this little bit right here that moves back and forth and reads the CD. These are pretty easy to get to. Okay, so maybe I lied just a little bit when I said they're easy to get to. That was a little bit more difficult than I had expected. Maybe the most difficult time I've ever had getting out a DVD burner. Huh. Well, you know, we're here now. Alright, so there are two laser diodes. Usually the DVD and the CD burner laser diode, and take a look at those and identify them. There is a vulnerable spot of which to attack from. Or the magnet in the screwdriver is non-existent at this point. Oh, right. Looks like here. On the upside, it doesn't have to go back together. Alright. Looks like maybe we only have one laser diode in this optical sled. 2 potentiometers. Where is the other one? That looks like the DVD. That looks like the reader. Alright, I'll wait. Maybe it's a combination diode. Let's find out. Usually the DVD burning laser diode is on its own little separate metal mount. That's that easy to break out. So it's like that. And it's a weird, goofy, open can style. Well, that'll look nice under the microscope, won't it? Now, really the best way is to break these out, and I'll be doing that in a little bit. We're going to put this one on the side, and I'm going to take one out of a laptop slim drive now. The upside is these are a lot more delicate and much quicker to break. So, here we go. Yeah. I don't really care about doing things the less violent way. Ta-da! Here we are. That easy. So this is a super multi-drive, so I'm betting that it's going to have one of those really weird little flat laser diode packages somewhere in there. Oh, nope. Looks to be a 3.8mm laser diode. Right here. So let's get that out. And there might be another one for the IR too. The CD. I'm not seeing it. Could be another little open can style. How to find out. From grip and snap it out. Oh yeah, definitely for the DVD. See if you can see that blue reflection off the little coating itself. That's an AR coating to prevent reflections back into the laser assembly. And when it's blue, it's for the DVD. It's a little bit of a greeny type of color when it's for the infrared alone, and you'll see that later on. So here we have our two red burning laser diodes, and I'll be extracting them from the little metal housing of which they're in. The best way to do this is with a little side angle cutters like this, and I'm going to be cutting the material away from the laser diode, and that way I don't have to put any kind of excessive force on it. And this is particularly important because they are both open can, so you have to be a little mindful of where you're cutting and how you're cutting, but it usually doesn't give me much of a problem. Ta-da! By a fluke of dumb luck, I have just removed two identical laser diodes. That's not exactly the way I wanted things to go. So, I have two more optical sleds here, and these ones have different laser diodes in them as well. This one has both the CD and DVD burning laser diodes separately, so one of these will be the DVD and the other one will be the CD. I'm betting that the one for the DVD is going to be this one, and it's usually, as I said, on its own little separate heatsink block, whereas you can see that the CD one is a little bit more recessed inside of the optical sled. So let's take those out and see what you get. These are both the 5.6mm common style laser diode. We'll get them out in no time. Well, there's one. And then we got this one, which I believe is the red for the DVD. That'll snap off. Just like that. And there's both our laser diodes. So, while they're still attached to the optical sled, I'm going to go ahead and desolder them. I'm going to pull the laser diode assembly out and away from the optical sled while doing that. Get some better focus on that. Excellent. And these are just two leads that need to be desoldered. Boom. And that is... oh yeah, that's definitely the red. So this is the IR. We can take a look at the AR anti-reflective coating on that one and check out the greenish color I was talking about. So on here, take a look. It has kind of a greenish type of reflection to it, whereas the DVD has a much more blue reflection. Boy, that's hard to see. And we'll quickly break those out of the little holder as well. Same method, using the little cutters. Got it right next to the laser diode seam right there. One like that. Grab it by the side. And we'll pull away the material. Just like that. That came out real nice. Boom. And this one, the DVD burner. Crunch. And there we have it. More laser diodes to play with. Let's take a look at the laser diode in this slim drive optical sled from a laptop. And as you can see, still not magnetized. I don't think I need that. As you can see, there's the little laser assembly right there. Yes, that is a laser assembly. So let's free that up. Get that laser diode assembly out. And there it is. Now let's take out the other laser diode for the DVD burner, which is located on the other side of the optical sled over here. There we go. And that is a DVD burning laser diode. Check this out. And I'll be showing you a little bit more of this in the video. We'll be connecting up one of these. So I have one of these, one of those laser diodes put in to a little module. And they work really well, actually. Yeah, let's get a bunch of laser diodes put underneath the microscope and take a look at the internal structure of the package of which the laser diodes are in, and get a better understanding of how to connect up and wire these laser diodes. So that way you can use any of these form factors of which I just pulled out, and then some, in your own projects. Here we are now underneath the microscope, and just for a relative size reference, this is a 5.6mm laser diode. We can also see the little canister of which is bonded to the top, and this little canister just prevents things like moisture or dust or impact from damaging the laser die on the inside of the laser diode. I've opened up one of these little laser diodes, and now we can see the inside of what's going on. And this is where the magic happens. Under higher magnification, we can see the laser die itself, which is this little rectangular block in the center of your screen. It's connected on the top and bottom, much like an LED and other PN junctions are, by two wires. So there's one wire right there, and there's the other wire right on the bottom. So this little rectangular block is the important thing that we're going to be looking for in these laser diode packages. So take a good look at it. It's pretty hard to miss, even though it's pretty tiny. Here's another form factor of laser diode.
and this one comes from the Xbox 360. I'm not really sure what this form factor is called, but it's basically a metal base plate with a plastic encapsulation around it, and the plastic encapsulation provides support for the lead wires going inside and electrical insulation. From the lead wires, you'll see that there are little gold bond wires that go to two semiconductor components. The first semiconductor component that's square and marked 29 is just a photosensor, and what that does is it detects how much light is coming off the laser die. And to the right of the photosensor, the laser die itself, which is a read-only laser die, so it's quite small, and has 3 bond wires. In most likelihood, this produces both the red and the infrared used for reading different optical media. I'll be using a couple of these form factor laser diodes for tests coming up later on in the video. They also do make burning laser diodes of this form factor, and you'll notice right away that the actual laser die itself is significantly larger. And this one is capable of producing anywhere from 150 to about 200 milliwatts of optical output. You'll notice that this one also has 3 bond wires, and is probably also capable of producing both the red and the infrared for different optical media. The general construction is the same as the one from the Xbox 360, where it's a metal base plate and the plastic encapsulation that houses the lead wires going into the laser diode assembly. Let's take a look at some more complicated form factors of laser diodes, and these not only have the laser die on the inside, but all of the optical sensors needed for things like tracking and reading the information off the optical storage medium. This one is about 8 millimeters long, 4.7 millimeters wide, and 5 millimeters tall, and has 2 rows of 7 pins, along with 1 case pin and 1 pin for the laser diode. Let's take a look at the inside of the laser assembly, and we can see right in the center there's the laser die with the output side facing up towards us, and to its left the sensor array. Under higher powered magnification we can see the laser die itself a little bit more, and we can also tell that it's directly bonded to the material that the laser diode package is made of, which means that the case pin, or the pin that shares continuity with the outside of the laser diode package, will be one of our electrical inputs. On top of the laser die is another gold bond wire, and that goes to an insulated pin on the rear of the laser diode package. To the left of the laser die is the sensor array, and it's basically a little processing chip that has several different photosensors on it. Here we have one of the older ceramic style of the all-in-one laser diode form factors, and it measures roughly 8 by 6 millimeters. This also has both the laser die and the sensors for reading the information on the optical disc. It has 10 connections, 5 on the top and 5 on the bottom, and I believe this to be a read-only for the CD-ROM. Let's take a look at the 2 major components on the inside of this laser assembly. Firstly, let's take a look at this piece right here, which has 4 gold bond wires on the top. If you notice to the left, you see a little gold rectangle, and that is the laser die itself. So that gold bond wire coming from the top of it is one of the electrical connections to the laser die. Above that, on the top of the larger block, you'll notice that there is another gold bond wire that is connected to a trace that leads to the bottom of the laser die. This will be the other electrical connection for the laser die itself. Underneath that, on the very bottom, you'll see 2 more gold bond wires, and this is for the photosensor that detects how much light is coming from the laser die. On this side is the sensor array. Once again, it's just an IC that has a couple of photosensors, but there's something to note between the 2 of those. Now that we're at higher magnification, there's something very important that I want to point out. You'll notice that the laser die is on the right and the photosensors are on the left. What I'm going to do now is I'm going to go down with my microscope objective lens, and I want to point out that I can focus on the area that is underneath the laser die. But what I can't do is focus on the area that is between the laser die and the photosensors. And the reason for that is this area right here is actually on a 45-degree plane and serves as a reflector for the laser die output. To demonstrate this, I'm going to be focusing on the laser die with the reflection of that 45-degree angle, giving us a 90-degree view of the output of the laser die. and you can almost kind of make out where the little gold bond wire is on the top. This is actually where the laser output for these form factors come from, a 45-degree reflector that bounces the laser light output at 90 degrees. This will be a very important thing to keep in mind while looking at the next two laser diodes. Let's take a good look at one of the most visually satisfying packages of laser diodes to look at. And this is the modern equivalent to the form factors we saw before that has both the laser die and all of the sensors for tracking and reading the information off the optical medium. It measures about 10 millimeters long, 4 millimeters wide, and 2 millimeters tall, and has 16 electrical connections, but only 2 of those connections we'll have to worry about. Let's take a look at the inside of the laser diode package. And as you can see, it's a work of art. With greater magnification, we can now get a more comprehensive understanding on how these laser diode form factors actually work. We take a look at the left side, we can see that there are 4 photosensors, and I believe that these are for optical tracking of the laser beam. We take a look at the right, there are a couple of rows of photosensors, and I think that these are for taking the information off the optical storage medium. Between both of those is the laser die itself, and I can see a gold bond wire on top of the laser die. This is one of the electrical inputs for the laser die itself, and underneath we can see a gold trace that is also powering the laser die. Both of these 2 connections lead to 2 gold bond wires that jump over a portion of the chip and onto 2 more traces of gold. These traces of gold also connect to 2 bond wires and lead to the 2 outside pins on one side of the laser diode case, which would be these 2 pins right here. Other things to note about these form factors of laser diodes are things like the little photosensor, of which is often located near the rear of the laser die itself and detects the amount of laser light that is being produced. And just like the previous laser diode package that I showed you, this one also has a 45-degree reflector that is located near the front of the laser die and reflects the light that is being produced up and outwards at a 90-degree angle from the top of the laser diode package. Let's now take a look at the CD burning equivalent to the DVD burner we just took a look at, and it's pretty much the same form factor that's often found in a optical slim drive pulled from a laptop. The only difference between the DVD burner and the CD burner is that the CD burning assembly often comes with this little plastic block that has a refractor on the top, but this doesn't prevent us from seeing the inside of the laser diode, and it's pretty much the same construction. There's the laser die, and on top of there is a gold bond wire, and that's one of the electrical connections. Meanwhile, underneath the laser die is another gold trace, and it's the same construction with the 2 jumper wires going over a portion of the chip, and then out to 2 of the laser diode leads on one side. Now that I've talked about the construction of various laser diodes, let's talk about the destruction of laser diodes. And for that, I have one of the Xbox 360 laser diodes mounted in this vise. They're capable of doing both the infrared and the red. I have the red portion of that laser diode hooked up, and I have a piece of white plastic here, which we can see the bare uncollimated output of the laser diode assembly. And all that means is that there's no lens in the front to focus it. Also, I have the adjustable power supply here, which is capable of both regulating in volts and in current, or amps. I'm going to turn off the light. First, let's regulate the amount of power going to the laser diode using voltage. And the amount of voltage the laser diode junction requires is often determined by the chemistry of the laser diode junction. As I turn up the voltage, I'm going to explain some of the characteristics. The first range we'll hit is the threshold range, where the laser diode starts to laze, which is usually anywhere from 1.9 to 2.1 volts depending on the size of your laser diode junction. And you can see that the laser diode itself is really touchy. This is a 5 milliwatt laser diode, so I have to be very cautious with how far I turn it up. After threshold, you'll start to get the nominal operating range. And after the nominal operating range, then you hit the peak output powers, which is where you start to risk damaging your laser diode junction. Now I'm going to show you right here, you can kind of see it. When we start to go past the nominal operating range and into peak, you're going to see some mode hopping of the laser diode junction, and it's going to kind of flicker and give us some patterns. So now we're into the peak range, and if I leave it here, the laser diode will actually start to dim out a little bit. And that's actually because it's warming up, and the laser diode junction is expanding, consuming more current, heating up more, and it starts a runaway process because it just feeds up on one another. Let's push it past the peak power and right into catastrophic optical damage, which is where physical damage actually occurs on the semiconductor mirrors. Is it dead? Let's bring it down and find out. No, it's not. More. I can't believe that laser diode is still working, honestly. More. Oh, it's dead. Okay, well we didn't go catastrophic optical damage, but we probably blew the little bond wire right off the top of the laser die. Let's go check out what happened. Well, this was unexpected. The whole laser die itself exploded. Luckily, we have more. Now let's cover controlling the amount of energy going to your laser diode using a current regulated power supply. And to help with that, I once again have the red LED that's pulled from the Casio Slim projector. I have my power supply set to 10 volts and 100 milliamps. So what happens if I connect up the LED to my power supply? We get a significant voltage drop, but the current holds at 100 milliamps. We have to think about the power supply like a factory. The voltage is the shipping speed of the electrons, and the current is the factory's ability to produce electrons. So when the demand for the electrons is exceeded, the voltage drops because they ship slower. So let's test out the voltage drop with a few resistors. Here's a 33 ohm. Same current, but not quite as much voltage drop. 24 ohms, we get more of a voltage drop. 2.2 ohms, a rather significant voltage drop. And finally 1 ohm. This is important because as a laser diode warms up, it becomes more conductive. And when something becomes more conductive, it wants to draw more current. In order to prevent a laser diode from burning out, Using a current regulated power supply is very important because this limits the amount of current that the laser diode is trying to take. Once again, I have one of the Xbox 360 laser diodes connected up to my power supply, and the voltage is still set to about 10 volts. However, I have the current set all the way down. Now, it can be very difficult to find a good data sheet for the particular diode of which you've extracted from your CD or DVD burner, so it's quite important to note the voltage ranges of the chemistry in the laser diode junction. I'm going to slowly turn up the current coming out of the power supply, and we should get a nice smooth ramp up to the diode's full output brightness. I'm going to bring it up to about 1.9 volts and see how that looks. Now, I'm not adjusting the voltage, I'm simply turning up the current. That's promising. Let's go for 2 volts. 2.1 volts. 2.2 volts. And yes, I am turning up the current very slowly. Oh, and it's dead. Here's where things get difficult, and this is because a lot of the laser diodes of which you extract from a CD or DVD burner have absolutely no physical markings. This makes finding a datasheet for them nearly impossible. So to help with this, I'll be running a few tests. I'll be doing some tests first with the infrared laser diodes, and when I do, I'll be using my full spectrum camera, and then with the red laser diodes. I have set up here my multimeter and a laser power meter. What I'll be doing is I'll be connecting up the laser diodes to this current regulated laser driver, and I'll be turning up the power to the laser diode until they die. Hopefully this will give me enough information so I can graph out where the voltage and where the current ranges are. This should help you connect up your laser diode without cooking it. I do these kind of tests so you don't have to. According to the test that I've just run with the CD burning laser diodes, it looks like the safe operating range is 2 volts at about 130 milliamps. This gives us a continuous wave optical output of about 70 milliwatts. Now, if this seems rather low to you, keep in mind that when the CD or DVD laser diode is writing to the optical storage medium, it's being pulsed, and pulsed energy can be significantly greater than continuous wave output. And continuous wave is just a fancy word for saying always on. Let's get into testing the DVD burning laser diodes. Well, it looks like we've collectively learned something today, and that is these particular laser drivers do not work very well with the red DVD burning laser diodes. However, I have a whole bunch of the red DVD burning laser diodes connected up to green laser pointer drivers, of which I've modified, and I'll be taking the voltage and the current measurements off these. And this will make a great segue into how to modify the green laser pointer drivers to operate with the red DVD burning laser diodes. With all the tests done on the DVD burning laser diodes, it looks like the universal safe range of which to drive them at is about 2.85 volts at 180 milliamps, and this will give you around 110 milliwatts of continuous wave optical output. Now, many channels will also show you how to use an LM317 voltage regulator as a constant current source by shorting out the output of the regulator with a resistor. Well, I'm the captain of this channel, and I say, don't even bother with that. So the next thing I'm going to be showing you is how to modify one of the green laser pointer drivers so that way you can use them with the CD or DVD burning laser diodes. Modifying a green laser pointer driver is actually really easy to do, and you only need to do this if your green laser pointer driver doesn't have a potentiometer. What's a potentiometer? It's this little thing right here, and you probably already have one. On an optical sled, there's usually two potentiometers, one for the infrared and one for the red laser, and the first thing you're going to need to do is take one of those off. The second thing you'll have to do is locate the adjustable precision shunt on your green laser driver, which is this little 3-lead piece right here. So the two resistors you're going to need to remove are these two resistors right here. The next thing that you'll have to do on your green laser pointer driver board is to find the 2 points that share a connection from the 4 points that the resistors were on. To do that, you can use visual inspection or a multimeter. And for my board, it's the two connections that are closest to the adjustable current shunt. That's where the sweeper of the potentiometer is going to go. And the sweeper is this little third pin right here, not these two. So let's go ahead and get this on the green laser driver board. Once the modification is completed to your green laser pointer driver, you should have an excellent source of which to control the current going to your CD or DVD burning laser diode. See, I told you these were great. Now it's time to put theory into practice, and for this I'll be assembling different laser diode modules using a mix of different laser diode form factors and laser diode hosts. For my power supply I'll be using this modified green laser pointer driver, and it's basically the same modification except this external potentiometer has a definitive stop point, so it'll make things go a little quicker. Let's start with the common 5.6mm laser diode form factor. You'll need a laser diode hosts and something to press your laser diode in with. On almost any 5.6mm laser diode, regardless whether it's a CD or DVD burning laser diode, the case pin is the negative connection, and this pin off to the right is the positive connection. Let's solder wires up to that. Solder. With those two wires in place, now we connect up the negative to the laser driver. And then we put the meter in current mode, and we put this into the loop. So I'll be soldering the red wire from my meter to the positive output of the laser diode driver. And then the negative to the positive side of the laser diode. And we'll turn up the laser diode driver until it reaches 180 milliamps. Ta-da! Now let's try one of the 3.8mm dual wavelength laser diodes, of which I extracted in the beginning of the video. I'll be running the infrared laser diode at 130 milliamps, and I'll be running the red laser diode at 180 milliamps. I already have one of them pre-mounted inside of this 3.8mm laser diode host. So let's connect it up and see how well it works. I'm going to test the infrared laser diode portion of it out first. Oh, that's nice. That works really well. Let's try the red. So that works really nice too. Yeah. Now we're officially going into uncharted territory, the bit of which I'm most excited for. Now we're going to use this form factor of laser diode, and you're probably wondering, how on earth would you actually do that? Well, there's one important thing to note first, and that is if you look on the bottom, the plastic dips down a little bit lower than the rest of the metal base plate on the bottom. Why is that important? Well, let me show you. I do actually have a solution for this. Here's my solution. Pretty simple. So the wiring is actually pretty easy too. The white wire is for the positive for the infrared, the black wire is the common ground, and the red is for the red DVD laser diode. Let's hook this up and see how well it runs. I'll be once again using 130 milliamps for the infrared and 180 milliamps for the red, and hopefully it goes well. Absolutely perfect. Now for the red. Oh yeah. And that's how you use that laser diode. Here's where I want to point out that you could actually do the exact same thing, and all I did was file the top off of this laser diode host, and I filled in the little hole with solder, and then just filed that flat. And you could do that with these kinds of hosts as well. So mounting them isn't as difficult as you may think. Finally, I'm going to show you how to use these form factors of laser diodes, and now that you've seen them under a microscope, you should have a better idea of what's going on the inside. So the first step is to locate the laser die in the center, and then the bond wires and traces that go to the pins on the outside of the laser diode package. And the two pins will always be in one of the corners on the laser diode. The most outer pin, in which case my upper right pin, is the negative, and the second pin in is the positive. Here's what I did to use one of those form factors of laser diodes inside of a laser pointer assembly, and it's pretty simple. So I removed the pump diode from the back of the green laser pointer, and I would also recommend that if you do this, to fill it up with solder. And the reason why I say that is because that little gold area right in the middle is actually the thermal contact for keeping the laser diode cool. In order to mount the laser diode, what I did is I simply just glued it on the top of this portion, just like that. And you can see my wiring on the side. So there's the outside for the negative, and then I just soldered all the other wires, including that second pin up for the positive. On the inside, I took the collimating lens assembly from the green laser pointer and cut the top off. And then I just put another lens in from a purple laser pointer. Earlier in the video, we already saw that the red one and the laser pointer assembly works just fine. So what I'm going to do now is I'm going to show you how to use one of the infrared ones in a laser diode host. The first thing to do is to take off the two outer tops of plastic, which protrude a little bit out of the top, and then to carefully remove the plastic block on the top. After you do that, you have to make some changes to your host, and here's what I did. So I used one of these, and what I did was I just fit the laser diode right in the middle. I also used a bunch of solder to plug up the hole, and then I filed that flat so it made good thermal connection to the back of the laser diode. And here's my wiring in the back. Let's see how well it works. I'm going to run this laser diode at about 130 milliamps, just like I did with the other ones, because so far it seems to be working pretty good. I'm going to run this laser diode at about 130 milliamps, just like I did with the other ones, because so far it seems to be working pretty good. A bad idea? That'll work. Hey, that's good. Oh yeah, that'll do real nicely too. Before you go to play with some laser diodes of your own, there's just a couple of important things I want to cover really quick. The first thing is, if you're gluing your laser diodes to anything, I highly recommend getting a fan like this. And what it does is it keeps airflow going past the laser diode window, or if it's an open can, the laser die itself, and prevents them from being damaged from any chemicals that are outgassing or any solvents that are in your glue. Secondly, the current ratings of 130 milliamps for your infrared CD burning laser diode or 180 milliamps for your DVD burning laser diode are just the lower safe ranges. Many of these laser diodes can go up to higher currents. And most importantly, I hope you enjoyed this video and I hope you learned something. As always, stay tuned for more.